Hello guys, welcome back to my YouTube channel, Just for Math. Okay, in this video I want to talk about quadratic equation by graphical method with GeoGebra. I'm going to explain to you how to solve quadratic equation. As a teacher, how do you explain the concept of quadratic equation? How do you teach it to your students in a more fancy method by leveraging on technology tools, which is GeoGebra? Alright, so I would like you to follow along as I carry you through this process. Okay, to show you the process or the procedure involved in solving quadratic equation by graphical method, I'm going to solve a WAEC past question. The question I'm about to solve is extracted from the past WAEC past question, June 2017, part 2, question 7. Here is a question, part 7a says copy and complete the table of values for the equation y equal to 2x squared minus 7x minus 9 for minus 3 is less than or equal to x and x is less than or equal to 6. So here is the table. It starts from, you can see we have two rows, x and y, with the range of values of x given from -3 to +6. Alright, all I'm going to do will be solving this from beginning to end using GeoGebra. Now, like I said again in my previous video, here is a fantastic tool that have always amazed my students whenever I teach them any mathematical concept with the tool. I've never seen a dull moment in my lesson when teaching with this amazing tool. So I would like you to pay attention. Make sure you watch this video to the end. Okay, I'll move on to my GeoGebra right now. So here is the tool GeoGebra. The first thing I want to do is to complete the table. In the introductory video I had with you guys on GeoGebra, I did mention that there are other windows that you can use. The CAS perspective window, graphics 2, 3D graphics, spreadsheet. So right now I'm going to use the spreadsheet window to complete the given table. Okay, now the table has two rows, right? X and Y. The rows from this table we form the columns in spreadsheet view of my GeoGebra, the spreadsheet in GeoGebra. I'll begin by typing the first variable x. Now if you notice that there is a quotation mark around x, that is to prevent the application or the tool from reading x as an input. Rather, I wanted to see it as merely a text, just a text. Once you do that, you press enter on your keyboard. Then the y variable, okay, x starts from -3 to +6, -3 -2 -1 0 1 2 3 4 5 6. Those are the range of values of x. Alright, to compute the values of y, you have to make use of the given equation, 2x squared minus 7x minus 9. Okay, the spreadsheet in GeoGebra works exactly as how the spreadsheet in Excel works. So it means for me to type in the equation in the y column, I have to begin with the equality sign, equal to 2 times x squared. This is the first cell containing the first value of x raised to power 2 minus 7x, that is minus a2 minus 9. So why am I doing this? Now I'm writing it in terms of the column or the cell name. so that I'll be able to copy or drag and copy the formula to complete other cells under Y. Now we have the first value under the table Y to be 30. What you need to do next, select that value, click on this little square and drag it below. When you do that, automatically the spreadsheet will copy the formula across all other values of x. Alright, now with this you can highlight the whole values, the whole table, and create a table. Come to the top left corner of your screen, the second tool, click on it and select table. I want to generate a table. I want to transpose it. I want it to look like the given table. Then click on free objects and OK. So in a future video, I will explain the difference between free objects and dependent objects in GeoGebra. But for now, let's just work with this. Okay, now I've successfully created my table. I can close the spreadsheet view and move my table around. Okay, so this is looking beautiful. Now that we have our table, let's go back to the question. So we've completed the table, task 1 done. Alright, part B says using scales of 2 centimeter to 1 unit on the x-axis and 2 centimeter to 4 units on the y-axis. Draw the graph of y equal to 2x squared minus 7x minus 9 for minus 3 less than or equal to x less than or equal to 6. Okay, let's go and scale the graph. 2 centimeters to 1 unit on the x-axis and 2 centimeters to 4 units on the y-axis. I'm back to my GeoGebra application. Then anywhere around the grids, right click and click on graphics. You move to the under basics. You can see this settings menu dialog displayed at the right side of my screen. Under basics, you move to dimensions. So for the dimension, I have the minimum value of x as -3 and the maximum value of x is 6. Okay, next for the value of y, if you look through your table, you discover that the minimum value of y is -15 and the maximum value of y is 30. Alright, now we can move on to the x-axis. The scale we are meant to use is 2 centimeters to 1 unit. Then come to the distance and click on 1. So this is 1 unit on the x-axis. You can expand this to increase or decrease the width of the space in between those values on the x-axis. Then move to y-axis, choose distance. This is 2 centimeters to 4 units. So I want to make it 4 units. Click on it and you can see it has taken effect immediately. Now once you're done with that, you can close this and visualize your graph. So this is looking lovely, right? It's looking great. All right, the next step I would like to take is to I have to mark my points, right? We have to mark our points on the xy plane on this graph. I want to mark my points, so that is exactly what I'm going to do next. So I'm trying to drag 3. I want us to see 3 minus 3 rather. So here is it. So let's go ahead and mark our points. How do you do the marking? We have to rely entirely, like I said, I'm relying entirely on GeoGebra to do everything for me. So I'll go back to spreadsheet. Now with the points selected, the values, don't choose the x and the y, don't choose the label, just choose the values from -3 to +6, including 30 to 21. You go back to the top left corner, this tool right here, click on list of points. Okay, list of points. It should display this dialog box. Let's call the list of points list. All right. Okay, now I'm going to leave it on dependent objects. Like I said, I'm going to talk about this in the future. Click OK. Once you do that, when you come to your algebra view, you discover that list of points has been created. So here is a list of points A through J. Those are the points, and on the graphics view you can see clearly that the points are marked already on the plane, your sheet. So you have the list of points marked, and you can see everything coming out beautifully well. Alright, the next thing I would love to do, instead of dot, I want these points to be a star or cross. So I'm going to select all the points, click on the first point, hold down Ctrl key and click on other points. Click G, H, click on the point I and J. Alright, then come to this top right corner of your screen, click on this circle and choose the cross mark. Then I don't want the labels to show. I'll hide those labels, so have just my points selected. Now if you like, you can change the color of those points if you so wish. So here are the points. Okay, next step to take is to get your curve, connect those points with a smooth curve. Alright, there are two ways to go about that. The first way is to use the command in GeoGebra. If you want the curve to appear automatically, use your command in GeoGebra, which is known as fit pole. So fit pole or fit poly. Let's fit poly. Choose this first one that has list of points and degree of polynomial. So the list of points, we have the points here titled list. Type it in list. Then the degree, we have degree 2. Immediately you do that, the curve will be fitted through those points. You can see that the curve is fitted through the points. The constraint here is that the curve will move from minus infinity to positive infinity. So the curve is drawn for all range of values across the graph. But since we have specific range of values from minus 3 to 6, instead of doing this, I'll prefer to use the if function. There's an if function in GeoGebra. So I want you to watch closely and listen, see how I'm going to type that. If minus 3 is less than or equal to x, which is less than or equal to 6, comma, I want to type the equation 2x squared minus 7x minus 9, and immediately you do that, the curve will appear within the range of values selected. This is looking nice and lovely. So you can decide to change the color and also increase the width of the line. So we have the line, we have the points, and everything is looking fantastic, right? Okay, the next thing I would love to do is to display the equation of this curve. So first off, let me hide these, the F, and type in the equation manually using the text tool. The text tool is under the tool, the second to the last tool. Select text and click where you want the text to appear. I want to see the preview of my text while I type it. 2x squared minus 7x minus 9. So that is it. So y equal to that equation. Then you click on OK. So once you do that, you can move this equation to wherever you want it to be, and if you so wish, you can also change the color of the text to be same color as the curve and click on bold to make it appear bold. Okay, once you're done with this, so it means we are done with the graph. Let's go back to the question and see the next question we have to answer. Question C says use the graph to estimate the 1 roots of the equation 2x squared minus 7x equal to 26. All right, let's quickly do some little calculation here. So we have 2x squared minus 7x equal to 26 is nothing but 17 plus 9. And the original equation which we've drawn its graph is 2x squared minus 7x minus 9 equal to 17. What this implies is we have to solve for the roots of the equation y, the point where y equal to 17 intersect with the curve we've already plotted right there. So what I'm going to do now, when I move back to my GeoGebra window, I will type in the equation y equal to 17 and check the point of intersection where the curve intersects with the straight line y equal to 17. I hope you understand that. Okay, let's go back to GeoGebra window and do that right away. Right now I'll type in y equal to 17, and that is it. Y equal to 17. Let's make it a broken line. Y equal to 17. Alright, so where are the points of intersection? We move back to the second tool, the point tool, and click on intersect. Select the broken line and the curve. You can see the points of intersection are at the points K and L. Let's actually show those values. Select those 2 points, click on this AA tool and select name and value. So as you can see, the point of intersection, which are the roots of the equation, the given equation, are minus 2.6, minus 2.26 and 5.676. Minus 2.626 and 5.76. You can also see that in the algebra window at the left side of my screen. Okay, that is solved. Next question says we have to estimate the coordinates of the minimum point of y. The coordinates of the minimum point of y is the turning point of this curve. So at what points do you see the curve turn? Let's see. If you check it, the coordinates will be the value of x here and the value of y. Taking those two, forming the coordinate with it, give you the coordinates of the turning point. You can easily determine or estimate by clicking on the extremum command or tool. Just click anywhere on the curve and you get the extremum point. So that is the extremum point M. Okay, if you want to see the point, you can actually view it at the algebra view, the left side of my screen, or you select the points, come back to this AA and click on name and value. Now it means that the extremum point, the coordinates of the extremum point is 1.75 comma minus 15.13. 1.75 comma minus 15.13. Now finally, let's answer the third question. Find the range of the values of for which 2x squared minus 7x is less than 9. Okay, how do we answer that question? We have to fall back to GeoGebra, type the inequality 2x squared minus 7x less than 9. All right, enter, and immediately the range of values we have is selected. So that is from minus x, and for minus 1 down all through 4.1 to 3 4 4.24, that is around 4.25. okay, around 4.25. In fact, if you want to be sure of that point, you can choose the roots of the curve. The roots of the curve, let's see what the roots of the curve are. The roots are at 4.5 and minus 1. Okay, with this you can be so sure of this the inequality. So it means the answer to the final question will be when x is minus 1 less than or equal to x less than or equal to 4.5. This is the answer to the final question the range of values for which 2x squared minus 7x is strictly less than 9. Okay, so here is one other fantastic way to make your math lesson fun by using GeoGebra to solve questions of this kind. Now, once you do this, you can imagine how thrilled and amazed your students will be when they see how all these things appear, all the points and the curve and the table appear as you're saying it and you are clicking on the command. Once more, this is a fantastic tool to teach. You can use to teach your students. I hope you enjoyed these videos, guys. Feel free to post questions in case you have any, and don't forget to like, share and subscribe to this YouTube channel. Okay, hope to see you guys in the next video. Do have a wonderful day. Bye bye.